Okay, hello people. In this video I'm going to be talking about how to implement growing array in C++. I have done already most of it, but in this specific session I will go through like the main functionality, and I will try to add some additional functions as well. So for example, functions for inserting elements into a growing array using iterators and using ranges. So for example, you provide like the iterator to the first element and then iterator to the last element, and then you insert the whole buffer into the growing array. And I will do some like minor experiments with memory allocation, because currently I'm just using malloc and free, which is kind of standard thing, but I will try to use virtual alloc and virtual free, which is the functions which you're supposed to use on Windows. And yeah, that's basically it. And the idea behind this project, it's not done yet. I just decided to program a bit and record the session, but the overall idea is that by the end I will try to compare like the performance between std vector and the custom growing array, and write Google tests and the benchmarks as well, and see what's the difference, and maybe like using custom arena allocations or something like of that kind. Right, but the goal is pretty simple: add insert functions and corresponding overloads, and then try to play around with virtual free, virtual alloc, and make sure that everything works correctly with the non-pod types, which basically, like for example, the custom data structures, or I wrote a custom string so we can utilize it and see how the growing array behaves. With that being said, let's jump into programming, and I will go quickly through the function that I already wrote and the interface of the growing array. Yeah. So as you can see, I have a single header file, and I added some to-dos here so we can follow them and mark them down as we go. So basically, this is the class for a growing array, right? It's a template class, and here are like iterator, the const iterator, type aliases, then the default constructor, then we can specify capacity, and then the initializer list as well, and then the destructor. And then we have like special functions, right? The copy constructor, copy assignment operator, move constructor, and move assignment operator. And then they have like a push back and front, and pop back, and the grow function as well. So then we have arrays overloads. So for example, you exactly the same as the standard C++ vector has. So we have like an arrays, and which takes a pointer, and another one which takes a range, basically. These are not implemented because they assume the const iterator, so we will have to like add the support for that. And these are the functions that I'm planning to do today, and these as well. The flush, what it does is just takes another growing array and swaps it. Clear, size, capacity, empty, left, all basic, all default. So basically what left, maybe you're not familiar with left, what it does is essentially the how many elements left to push in order to make the buffer full, right? In order to invoke the next growing function, in order to force the array to grow, I would say this way. And we just, let me give you an example. So for example, we allocated 16 elements. The capacity is 16 elements, and we have already pushed like 5 elements. So then the difference, 16 minus 5 would be like 11. And there are some iterators, begin, end, those kind of things. Allocate memory, free memory, 0 members. We'll take a look at that shortly. And then we have the actual data. Then we have a size and the capacity. Here is the default constructor, doesn't do anything. And okay, never mind. Then we have the capacity. And I don't check whether the capacity, what is the value of the capacity here. Probably that would make sense that if I specify, for example, and that might be an integer, and in that case I would have to check whether it's greater or equal to 0. But yeah, what we do is we allocate memory here, and we assign to m data. We don't touch the size at all. Here we pass an initializer list, and what we do is we iterate through each element in the list, and we push it back to the underlying storage. The destructor frees the memory, which calls like an underlying free function. I can show you. So free memory, just free, and zero all the members. Then operator, it's a copy assignment operator. So we check whether we are trying to assign to itself, and then in that case we don't do anything. Let me grab some water quickly. Then we copy the data that we had. We free the underlying storage. We set the size, capacity, and data, and we return the pointer to these object. 0 members. We set all the members to 0. Accordingly, then the move constructor just sets m size from right hand side. Size, the same applies to capacity, the same applies to data, and then we 0 the members for that object. Move assignment operator, again, I wasn't sure whether I had to implement this, but I think it's correct because most likely you can let me sketch out like the implementation super quick. So for example, I have a growing array here, and this is the string s1, for example, right? And then we can do the same. We can do the same, and then the next step would be we can say, okay, S1. So I just move in from itself, right? And in that case, let me just double check what happens, because I wasn't sure that it's even legal, but apparently it is. So let me debug. Yeah. And okay, so we can see we're trying to move from itself, which doesn't really make any sense. We cannot 0 itself and then reassign, and just stupid, right? So that saves us from that kind of situation. One bug out of the pile. So this is not necessary. I was debugging. This is just allocation memory function. Although what we could do is we could do this. If defined Windows 32 and if I'm just imagining, right? And here Windows.h, and this is not how you should include Windows.h. You should do it differently. But then, like, okay. And here, what I wanted to do is call virtual alloc. And this can be 0, and the size is actually the allocation size, right? We can, can do it like that, and we can specify the allocation size, and then we can memory reserve, I guess. Page read write, and these sets like the memory to 0 by default, so we won't have to call memset, right? And then we return the memory, and the static cast is not even necessary. So we return the memory back, but that allocates the whole page. And here we could do the same, but for the like free. If defined Windows 32, for example, else and if, and probably I should have done it in a separate, like, yeah, that works. That works. I can keep it like this. So here we can put the free function and virtual alloc, not a virtual alloc, but rather virtual free, right? And then we specify the address, memory, and we can maybe cast it to lp void, since we're already on Windows. If we set size to 0, that would mean that we don't have to the whole like chunk of memory will be deallocated, and the flag that we have to set is release. I assume. So this is how it works, and we can keep it. We can put it here, so it's kind of okay. Great, and so we can experiment with that as well. I can remove those things, I can remove this. Yeah, so here nothing special. Pushback, which takes an object, the reference, and the R value, and then we move from that object, and we insert, and we grow if necessary. And we compute the capacity by taking the maximum out of 16 and the left shift by 2. And then we have the back element, the front element, which asserts if we are trying to get retrieve the back element on an empty underlying storage, right? And then what we do is we just increment the size, and we return reference, const reference to the object itself. And here is the same, but 0. Yes, okay, that's all right. Pop back, just decrements the size, but before that, or it can be done even after, it doesn't really matter. We just free the memory, not free the memory, but we zero the memory that was occupied by that object. It's not necessarily just the convenience approach. The grow function itself, what it does is we check whether the capacity supplied is less or greater than the initial capacity, and in that case we return false, and here we allocate the memory. Yes, we allocate the memory. We check whether the mdata, which is the underlying storage, is equal to null. Pointer, if it's not, we copy all the data to the pre-allocated memory, and then we free the underlying storage, and then we reassign some members. Clear function sets size to 0 and clears the memory if necessary. Erase. What erase does is we provide an iterator, and we iterate over and we erase element exactly at that place, right? And then we have to, and basically what happens, and you can read even the documentation of std vector, what happens is that all the iterators after the element that have been erased are validated, right? Because we have to move them. We have to iterate from the element where it was erased up to end, and then we have to copy all the elements one by one. So we have to shift them, which invokes the copy assignment operator on each object, or the copy assignment operator. So this is what we do, and we decrement the size by 1, and what it returns is actually the iterator to a new element, right, that have been placed into that position. The same for iterators arrays on range. So we provide like the first element, the iterator, the first element that we have to erase, and the last, not inclusively, and we erase all those elements in between. So that is one thing, and I have a couple of functions left here that I would have to implement. But let's double check that everything works correctly with virtual alloc and virtual free functions, because I haven't tested that yet. So here what I have is I create a growing array, I grow it, display size capacity, and then I push an element back. And I don't even think that this is necessary. Okay, and we try to compile again. Okay, we iterate, and then yep, and you can take a look. We have our string as expected, which is great. Let's put some more elements. Okay, so let's test the erase procedure. So for example, erase, and I want to erase the first element, and what it would return to me is an iterator to the element that was placed in the position of begin, right? And then I check the size. The size should decrease by 1, and then I will try to print an iterator, and most likely that will fail, because or there will be nothing. My first element. Yeah, since we didn't zero the memory, but you see the size is 0 here, which is correct. Let me take a look at main. And if you try to display, the array would be empty. Display as... we can do it later. Growing array. Okay, so let's just figure out how do we do insertion. Okay, so we have the place and we have an object that we need to insert at a particular place, at that place, right? I wonder how should it behave. Let's just take a look at std vector, for example. Vector ml string string, right? As vector. And then as vector insert. Let's maybe push a couple of elements. Let's push like 3 elements. String first. Okay. Second. Second, and then third. So we have the first element, the second element, and the third element. And probably it would make sense to as vector reserve. Let's just reserve the space for 3 elements. And I'm not even sure whether I have like the implementation for the vector, because I only have for the growing array. Well, what we could do is container and container, so that works, and then we can remove it here, so that we can actually reuse that function for displaying the vector. Okay, let's try. Too many breakpoints. It's too many breakpoints. Okay, so we have first, second, and third, which is correct. And let's try and see how it behaves. Insert, because I don't remember on top of my head. The iterator. Let's just say that as vector begin +2, or rather +1, and then string new object. So we insert, and then we say that. I mean, probably the size should increase, right? As vector size. Okay, so the size is for elements now, which is expected, right? And we can display So we inserted it before, and that should return an iterator back. And let's see what kind of iterator does it return. Does it return like an auto iterator? Did we occupy? Yes, we did occupy. Okay, svec iterator, and then cout iterator svec iterator, like that. And what it's complaining about? Okay, so it's a string. We would have to dereference. Okay, let me double check whether you can see. Yeah, I think it's pretty alright. Iterate a new object. And okay, so it returned the iterator just to the new object that we have inserted. Okay, makes sense. Okay, so how would we implement it? We get a place and we get an object. And in the future, when we move from iterators being implemented as pointers to nested classes into the growing array, I think we can get rid of assertions and move it into the nested class itself. But right now, that's how it's implemented. And what we have to say that place greater or equal than begin, because we can insert like to the, although I'm not sure whether we can insert at the end. Let me read the documentation quickly. So insert is the D vector insert inserts elements at the specified location in the container. Inserts value before the position. Okay, so it's actually before the position. Insert count copies. Okay, that is not relevant to us. If after the operation the new size is greater than old capacity, a reallocation takes place. Okay. All right. If after the operation the new size is greater than the old capacity, a reallocation takes place. In this case, all iterators, including the AND iterator, and all references to the elements are invalidated. Otherwise, only the iterators and references before the insertion point remain valid. Iterator pointing to the inserted value. Okay, so what does it say? Is greater than the old capacity. If after the operation the new size is greater than, okay, the allocation takes, in which case all iterators included the AND invalidated. So I would assume that we can actually supply the AND iterator, but I'm not really sure. Place and then the place less than the AND iterator, but this is like before, so it will insert before this element. And I will make a note. If place equal to AND, let me read the documentation one more time. Iterator before which the content will be inserted may be AND iterator. Okay, that's correct. So it can be an AND iterator, and then in that case we insert before. But could it be a begin? I'm just wondering whether it can be a begin. Let's do like this. And let's see. Yes, apparently we can. We just inserted before. Okay, and we move all the objects like after. Yeah, it can be either begin and in this case the element will take place instead of end. If place equals end, we put the element right before the end iterator, and which becomes invalidated. Right? Okay. So what we have to do? Yeah, okay. And this is actually if m size, m capacity, and the size new capacity max. If you don't have any elements in the vector itself, that would be 0. Okay, we can put 1, capacity 2. So basically the idea behind this solution is that when m capacity is 0, then shift will give us 0, and in that case we just use 1 or 16 or whatever, and then we use the grow, I guess. Let me see how it's implemented here. Okay, it doesn't return anything, just reassigns internally. New capacity. So we grow the size. Don't forget to increment the size somewhere at the end. And okay, so we get a place and an object. So that points to, for example, let's assume the situation when place points is begin iterator, then we would have to move the object from begin into the next location. So it's most likely will be like a for loop. I don't know whether you can see something or not. I'm trying to... maybe it's better so I can move it on this side. Yeah, okay, hopefully it will become better. So what we do is that and we have grown this in the capacity, right? So we have enough space. At equals place. At doesn't equal and. At plus plus. add plus plus, and then it's basically add plus 1 equals at. Greater or equal, less or equal than the AND iterator. Since at this point it is safe to do this because we we have grown our array, and that would return us the place iterator, right? I'm not sure whether that's like the best solution possible, because okay, let me think. So we say that at equals place, and at equals place, we assign the at equals place, right, and then at plus equals at. Now we just override the object. Okay, I see. This won't work. This won't work. Okay, so this approach won't work. Doesn't equal place. But this will do the trick, I guess. And then we say that, okay, place equals object. And then we increment the size. And here, what we have to do is so basically swap the elements. At equals at -1. And if place equals the begin iterator, if at doesn't equal to begin iterator, then we do this, right? We say that at the current start at the end of the iterator, and the end of the sequence, and decrement one by one. Begin, okay, okay. If +1 then we do the same. So this would be the begin element, and this is the current element, which is an empty slot, right? And in this situation, we would have to break out of loop. Yeah, that should be correct, but obviously we would have to debug it thoroughly. And let's comment out our vector, because we don't need it currently. And let's see. As push back. So since here we have no elements at all, let's push a couple of strings. And I'm wondering, yeah, it should work on the empty one as well. So we can do insert and string newly inserted string, right? And yeah, it's begin. And that should return the iterator, but we are not interested in that. We can just, okay, let's just display the whole thing. Okay, let's just try. 42 minutes. Okay, that's not great. Must return the value. Insert must return the value, and but I think it does, no? Oh, right, because that's the move operation. Well, we can just copy paste and do exactly the same trick here. I'll restructure it a bit. Okay. Like the only difference, and I will figure out it later, how to restructure, how to structure the code better. But basically, what we do here is std move. So we dereference the pointer, and we move the object inside that pointer. Inside that location, I would say. So let's see. Okay, as usual. Yes. Here is our this, which is mdata. Newly inserted string size ++. Then we return the place. And the place holds a newly inserted string, right? And then we can print it, and here is our element, which is correct. Okay, how can we... Yeah, that's all right. And let's insert one more element, C begin as well. And that should be a different string before begin. That should be before begin. Yes, that's correct. So here is our this, and newly inserted string. But did we move the object? Apparently we didn't. and I can use display function to verify that. And let's take a look. Before begin and newly inserted string. Yeah, that's alright. That's how it's supposed to work. Great. So we have 2 elements so far. Let's add one more. And this time we specify and iterator. And we say at the end. Right, and then we verify that display actually see out and then what we do is I wanted to take a look at this size. Right, and I want to take a look at the size, and hopefully that will give me the answer that I want. And here we have before newly inserted string and at the end, which makes me think that everything works as we expected. Now with ranges, and let's actually try to insert like an object somewhere in the middle. And well, we can actually simplify this a bit, right? We can remove the parentheses here, and well, it doesn't look nice. No. Okay, string. New object in the middle, and this is the object in the middle, right? And let's specify begin, and we've seen that this is actually the first and the second. Let's specify between the begin +1 and the end. So +1 and then object display as, and then these has to be copied as well. Oops, that's not great. Where does it come from? So we have a call stack. I guess it comes from the iteration here. Okay, I see. Okay, so let's debug it step by step. Nope. That was a Google test that I was intended to use. So C begin +1. That should give us the right location. Yeah. So where is the place? And the place is newly inserted string, right? So what we do is I would assume that the logic somewhere here is incorrect. So it doesn't equal to place. Okay. Greater than place. Oops. Yeah, that's not true, because what we have to do is to. So only in this case we should break, right? Okay, I see. I see. Let's try this. Error, syntax, and expected token. Okay. Okay, so now it worked, and in the middle. So we put it before. Yes, that is correct. Because if you specify begin, then that would be an actual plate of the begin. So we would put it before begin, right? But now we put it before a newly inserted string, and we have the size 4. Okay, great. All right, and like the next step would be to test how do we insert ranges. And this is basically the same, but it specifies the count, how many copies of this object we want to insert. And as you can see, it passes by the reference because we cannot overload this function for the R value reference, because we cannot move from object more than once, obviously. Okay. I don't know. I think that would be it for today, because I will try to keep the series short, but maybe I will make like more of them. So by the end, I have like a complete implementation of the growing array, and so like maybe I make a playlist where I just talk about it and do some programming. But that would be it for today, and thank you for following me. I hope that was helpful and you learned something, at least how it can be implemented under the hood, so it's not a mystery how STD vector works. See you later.